Welcome. Today we're here in Madison, Wisconsin. It's late October and Halloween is just around the corner. Students everywhere can be seen flocking to their local party city where they desperately search for costumes in the frigid 35-degree air. But it wasn't always like this. Just 2 days ago, it was a balmy 75 degrees. The sun was out and all was right in the world. So what exactly happened? Alright, now that we're back in the warmth of my dorm room, we can look at the forces that drive weather here on Earth. So we can see that solar radiation is constantly released from the sun in every direction. And apologies to any flat earthers who might be watching, but the Earth is in fact a sphere, which means that radiation is more spread out and thus less intense at higher latitudes, which is why us Midwesterners tend to get horribly sunburnt when we fly to Mexico for spring break. This uneven heating creates pressure and temperature gradients in Earth's atmosphere. Factor in the Coriolis effect because Earth is constantly rotating, and what we get are three distinct circulation cells in Earth's atmosphere. These cells help circulate the air, drawing warm air away from the equator and cold air away from the poles. But Earth's axis is tilted. This means that in the winter, the northern hemisphere receives a lot less solar radiation than the southern hemisphere. During the winter months, the lack of heat from the sun causes the polar cell to intensify, pushing the jet stream south and bringing cold polar air down over the US. So now we can see why temperatures drop, but what exactly causes them to shift so dramatically? Well, the cold polar air isn't the only air mass that covers North America. There's also a warm tropical air mass that dominates lower latitudes. During fall, the polar air gets even colder and the tropical air loses heat as well. The polar air moves constantly, and when it moves south, it forces less dense tropical air up into the sky where it cools. As the air cools, it drops heavy rain or snow along the boundary. These air masses don't really mix due to the differences in density, so when polar air moves over a region, cold winds move in and temperatures will start dropping extremely fast. Once the cold air moves over a region, it will likely remain cold for multiple days or even weeks. When this happens in the late fall, the polar air mass becomes more stable over mid-latitudes, which means if you're in Madison like me, it likely won't warm up again till spring, because even the tropical air mass will start to cool off as we get closer to winter. So there we have it. Now we know why it's so cold out. And next year, when you go to watch the Badgers lose to Ohio State for the 14th year in a row, it'll all be okay. Because everyone else will be freezing, but not you. You watched this video. You checked the weather, and you wore your $350 weatherproof insulated North Face parka from REI that your rich grandma bought you for Christmas 3 years ago. Thank you for watching. Have a nice day, and roll Badgers.